Hi class, so today I'm going to start by making a little video for Sapling homework number 15. So this was another request, so thank you, Serena. So this question is a great question, I really like it. There's some good problem solving that we need to sort of go through. So what I've done here so far is just write out the question as we see it on Sapling. Your numbers are probably a little different, your gases might be different, but the method and the strategy are exactly the same. That's what I'll talk about today. So it says that our gas mixture is made by combining 8.3 grams of argon, neon, and some unknown diatomic gas. Diatomic just means that it's made of two particles, right? So O2 would be an example of a diatomic gas. H2 would be an example of a diatomic gas. At STP, the mixture occupies a volume of 16.49 liters, and we're asked to find what the molar mass of the gas is. So what I might do is I might say grams over moles and put that in a box. That's what we're looking for, right? And we know the grams already, 8.3 grams of an unknown diatomic gas. So really what this question is asking is how many moles of that diatomic gas are in my sample? So that's really what I'm looking for to solve. So the next thing that I'll do is sort of organize all the information that I've been given. So 8.3 grams of argon, 8.3 grams of neon, 8.3 grams of my unknown gas, and then my temperature, pressure, and volume data here. Now, keep in mind at STP, according to Sapling, that's going to be 273 Kelvin. That's a little different than when we're talking about standard conditions for thermodynamics. So in chapter 6, we say standard conditions or STP. And we're talking about 25 degrees Celsius or 298 Kelvin. So on Sapling, if we see STP, we're going to use 273 Kelvin. And I'll just be very clear about that as we go through this class, what I want you guys to do. But for Sapling, STP 273. Okay, so the first thing I'm going to do is I'm going to convert from grams into moles. So using the molecular mass of argon and neon, I can convert those masses of argon and neon into moles of argon and neon. So for argon, 39.95, and that's going to equal 0.208 moles of argon. So in my sample, that's the number of moles of argon that I will have. For neon, I can do the same thing, 1 mole over 20.18 grams. And that's going to give me 0.411 moles of neon. So right away, I know the number of moles of argon, I know the number of moles of neon. I do not know the number of moles of my unknown gas because I don't know what the molecular mass is, right? That's what we're looking for. So using this information down here, I can solve PV equals nRT, and I can solve this, and that's going to give me the total number of moles in my entire system, right? So if I go back to my question, at STP, the mixture occupies this volume, and that's the mixture of all of the gases. So if I use PV equals nRT, so my pressure is 1, 16.49 equals N, and then 273 as my temperature because of STP for Sapling. So then if I solve for N, that's going to equal 0.736 moles. And again, right, doing that sort of notation thing, this is my total moles in my mixture. So that's my total moles in my mixture. I can now use this other information to solve for the moles of my unknown gas. So 0.208 plus 0.411 plus whatever my moles of unknown gas should equal this 0.736. So we could rewrite that as total moles equals moles of argon plus moles of neon plus moles of U, where U is my unknown. So if I do that and I solve for moles of U, that's going to equal 0.117 moles. And now to find my grams over moles, right, for my unknown, I'm just going to take 8.3 grams divided by 0.117 moles, and that gives me an answer of 70.9 grams per mole. Now, let's do a quick significant figure check. My masses are just two significant figures, 8.3, so really my answer should be 71 grams per mole. The last step on this question is just to identify the unknown gas, so just finding whichever gas has that same mass, keeping in mind that those are diatomic gases. So if it's O2, we're going to take the mass of oxygen, 16 times by 2. So for this one, this must be Cl2, because each chlorine weighs 35.45 grams per mole, and 35.45 times 2 is 70.9 or 71 grams per mole based off of our significant figures. All right, thanks for the request.